Hey, what's up? It's your old pal, Mr. Cook. We're going to go through the Unit 9.3 notes for honors geometry, going over Hero's formula and Brahmagupta's formula. Hero's formula, first off, is more commonly known as Heron's formula. I think in our geometry textbook, they write it as Hero for some reason. I think it's kind of interchangeable. The more acceptable one that I've heard is Heron's formula. These are just two formulas that you can use to find, in Hero's formula or Heron's formula, it's the area of a triangle. And then for Brahmagupta's formula finds the area of what we call a cyclic quadrilateral. And I'll kind of describe what goes on for both of those. They're very similar formulas for area, so that's going to be nice. If you know one of them, you got to know the other one pretty easily. So let's just get to it. All right, we won't derive these, but I'll show you how to use them. Recall from Unit 6, we learned how to find the area of a bunch of triangles. One way that we found it was area of a triangle is 1/2 the base times the height. So that's the main way that you learn how to do it. If we apply that with that's one way to find the area of a triangle. There's actually going to be, I think, 3 total ways. So this is another way to find the area of a triangle if you have all 3 sides. There's going to be another one that we're going to learn in a little bit with angle measurements. In fact, I don't know if we actually already have learned it. It's going to look like this. It's 1/2 the 2 sides of a triangle times the sine of the angle between them. I think you might learn that in trig, maybe. But yeah, that's another way to find it. So those are 2 that you already know. So there's the first one and second one for side lengths and angle measurements. But this third one just requires you to know all the side lengths of the triangle, and if you know that, then you can use it. First thing you need to find is something called the semi-perimeter, which is what it sounds like. Semi means half, so half of the perimeter of the triangle, and then you just simply plug it into this equation over here with A, B, and C being the side lengths. So find the area of this triangle. Okay. Let's be honest about this. This is a 5, 12, 13 triangle, so this is a right triangle. So even though I can use Heron's formula, I'm just going to use the normal one that I know. Area is equal to 1/2 the base times the height. This example is used to kind of show you that you can still find the triangle's area, with regular means. So from just 1/2 base times height, but you can also find it using other methods. Okay, so this is the most straightforward one, 1/2 base times height. So it's going to be 1/2 of the base and the height need to be perpendicular to each other. So 5 and 12. So 1/2 of 5 times 12. 5 times 12 is 60. 60 divided by 2 is 30. So it's 30 units squared. But I'm going to show you can also find this using Heron's formula. It's going to take a little bit more time, but you still get the same area, 30. So first we find the semi-perimeter. So that's going to be 1/2 of all the sides added up. So 5 and 12 and 13. So 5 and 12 is 17. 17 plus 13 is 30. 30 divided by 2 is 15. So the semi-perimeter is going to be equal to 15. Okay, and then from there we just plug in 15 here, here, and here. And then for the side lengths, we plug those in here, here, and here. Okay, so it looks something like this. The area of the triangle is going to be equal to the square root of the semi-perimeter, which is 15, times the semi-perimeter minus each of the side lengths. So minus 5, 12, and also 13. So 15 minus 5. 15 minus 12, and 15 minus 13. All right, let's simplify it a little bit. So let's see here, 15, and then 15 minus 5 is 10, and then 15 minus 2 is 3, and then 15 minus 13 is 2. Okay, and then let's see here. Now, if I multiply all these things together, that's 10 times 15 is 150. And then 2 times 3 is 6. 6 times 150 is going to give us 900. And the square root of 900 is 30. So see, we still end up with 30 either way. But just thought I'd show you how to use it. This is not a right triangle, so we can't use 1/2 base times height. So we're kind of forced to use the other one, Heron's formula. So let's find the semi-perimeter. That's half of all the sides added up. So let's see here. 18 and 22, that's 40. 47. So 47 over 2 is a semi-perimeter. So that means our area is going to be equal to the square root of the semi-perimeter times the semi-perimeter minus each of the sides. So 47 over 2 minus 18. 47 over 2 minus 22. And then 47 over 2 minus this last one, 7. And then, just type it into your calculator, round to 3 decimal places. And then it's that many units squared. Okay, but that's how you find the area pretty easily. Okay, now Brahmagupta's formula, it's the same idea as Hero's formula, except for one thing, it has a fourth side. So we kind of can assume that this triangle has 3 sides because the fourth side is a length of 0. So, Brahmagupta's formula has always been there. It's just sort of like applying it. It only works for these things called cyclic quadrilaterals. And cyclic quadrilaterals are ones that can form a circle around its vertices. Okay, so like in other words, each of these points right here, like you can fit them in a circle. This isn't going to work every single time for every quadrilateral, but for these ones it would. And you basically just do Hero's formula again, but instead of that first one being an S, it's going to be an S minus a side length. So each one of the S's has a side length attached to it. So here's how you find the area of one of these cyclic quadrilaterals. You can describe quadrilaterals. So you find the semi-perimeter first. So that's a half of all the sides added up. So 4 and 6 and 5 and 1. So let's see, that's 10 and 6, 16. 16 divided by 2 is 8. So the area of this cyclic quadrilateral is going to be equal to the square root of the semi-perimeter minus each of the sides. So 8 minus 4, 8 minus 6, 8 minus 5, and then finally 8 minus 1. Okay, so that gives us, let's see here, 8 minus 4 is 4, 8 minus 6 is 2, 8 minus 5 is 3, 8 minus 1 is 7. So that's 8. Well, let's simplify it, okay? Because I know that out of 4, you can take the square root, so let's take a 2 out of there. And then 2 times 3 is 6, and 6 times 4 is 42. So square root of 42. And none of those are reducible any further. So there's your area. It's 2 square root of 42 units squared. All right, last example. Just do it one more time. So find the semi-perimeter first. S is equal to 1/2 of, then add up all the sides. 2 and 6 and 7 and 9. All right, so 2 and 6 is 8. And then 8 plus 7 is 15. 15 plus 9 is 24. Half of 24 is 12. So I think 12 is going to be our semi-perimeter. Let me double check that. 8 and 9 is 17. 17 plus 7 is 24. Yeah, 12. Okay, so then we plug it in the formula. Area of the cyclic quadrilateral is equal to the square root. And then we take the semi-perimeter and subtract away each of the sides and multiply them together. So 12 minus 2, 12 minus 6, 12 minus 7, 12 minus 9. All right, and then, simplifying all that stuff. So 12 minus 2 is 10. 12 minus 6 is 6. 12 minus 7 is 5. 12 minus 9 is 3. And then let's see, can we reduce this any further? What do we get? That's 60. And that's 15. So then 900 again? Am I crazy? No, it's 900. So square root of 900. So that's going to be 30. So our area is going to be 30 units squared for this one. Okay, so that's how you use Heron's formula and Brahmagupta's formula. Just put them on a list for, start compiling a list of your different area formulas. That way you can decide which formula to use in which situation. It makes it a lot easier for you. Okay, that's it for this video. Hope you found it fun and helpful. If you need some more help, go find your geometry teacher, get some help from them. Otherwise, you can come find me. I'm Mr. Cook. I'm always available before and after school. All right, thanks for watching. See you in the next video. Bye-bye.